This podcast is recorded at the University of Sydney's Camperdown campus, on the land of the Gadigal people of the Eora Nation. They've been discovering and sharing knowledge here for tens of thousands of years. I pay my respects to elders past and present, and extend that respect to all Aboriginal and Torres Strait Islander people.
Yes, when I talk to it, it is a little bit like I'm talking to it as a person. As I said, I'm using it as an assistant, AI assistant, and it's a little bit like having a colleague. I don't see it as a parent-child sort of relationship in either direction. I'd see it as an equal, and so I'm interacting with it. I'm choosing to interact with it in that way as a colleague or an equal.
Before tools like ChatGPT were commonplace, the major concern about AI was that it would come for our jobs, all of our jobs. But in recent years, the conversation's changed a bit. Analysts seem to agree that AI isn't necessarily coming for your job. Rather, most of us will have to learn how to work with AI and do that quickly. Meanwhile, even as the applications and benefits of AI grow, so too do the concerns. How do the large language models like ChatGPT and Claude continue to develop? What does it mean that almost all the tools come out of the same American city? Are the rapid gains of the last 12 months about to plateau? And finally, will we get that digital assistant that we've been promised? Sandra Peter is Associate Professor at the University of Sydney Business School and Co-Director of Sydney Executive Plus, an experimental space for the application of cutting-edge technology in business. Sandra, you've said that everyone will have a relationship with AI in the future. What kind of relationship are you thinking about?
Thanks for having me, Mark. Yes, I do think all of us will have a relationship with AI, whether that will be building it, working alongside it, working for it, thinking about how to govern it, even befriending it, maybe marrying it.
How to marry it. We might get to that down the track. Look, if we're all going to have a relationship with AI, we need to get a better understanding about where it's all started to understand our partner better. Now, this all goes back to a conference at Dartmouth. Tell us about that.
The famous 1956 conference, everyone talks about it as a conference. It was really more like a 2-month-long workshop. And to be fair, it was more like a 2-month-long summer camp where 45 blokes got together. 11 of them actually showed up to the meetings and spent a summer together trying to figure out how to build intelligent machines. This is 1956, it's almost 69 years ago. Elvis's Heartbreak Hotel's playing and people are figuring out what James Dean's rebellious legacy is like. And they're together on a campus much like the one at the University of Sydney. And they think that we could teach machines, if we could just teach machines everything that we know, they could be like us. And they were very, very optimistic about how long this would take. The idea was that in about a year, and some people were more pessimistic, it would take maybe 2 to 5 years, we would teach machines to be like us by encoding in them every aspect of learning that we know. And to do that, we basically started teaching computers rules, the rules to chess, the rules to decision-making. We would describe objects. And that actually worked really, really well. Except you can't teach everything to a machine. So lots of excitement in the beginning, lots of interest in the applications, lots of defense interest, lots of money pouring into this. But very soon we find the limits of this kind of technology.
Was it an underestimation of the complexity of the task in practice?
Very much an underestimation and a conviction that our brains kind of work like computers, and if we could just download everything into a machine, encode it into the machine, then we could make this work. And these expert systems, as we call them now, still exist. Rule-based algorithms still exist till today. You call up a call center, press 1, press 2, triage still works that way. But the excitement in that very, very quickly dried up and the money dried up.
There's lots of technology that we use every day, from the motor car to turning on the television set, so many other things that we really we don't really understand or need to understand or appreciate the origin story, the background, how it all came together. But there are some who argue, look, we really need to understand how AI came together and how AI worked, because it's fundamental to appreciating the strengths but also the weaknesses.
I believe that's very true in the case of AI, regardless, if you're a student in school or if you're running a multinational corporation, because this technology works very differently to how we normally understand computers to be, or even how we intuitively think technology works. And it's helpful to think about this first wave of AI, the Dartmouth wave of AI, because that's how we intuitively think computers work. And we abandoned that kind of research pretty much in the 60s. And up until the 80s, we couldn't really figure out how to make this new wave of tech work. And other than nerds in universities like us, no one in business or government really had an interest, but nerds in universities back in the late 70s, early 80s, figured out a completely new way of doing tech, which is what gets us to ChatGPT today. And the idea was, don't explain to the computer everything, all the rules to the world that we know, but rather show examples to the computer and let it figure out patterns from that data. Let's talk about how we encode images, for instance. Say I'm trying to recognize a handwritten letter or handwritten number, say number 8. The way I would recognize that is I would show the computer lots of number 8s. I would say this is a number 8, and it would encode an average 8ness, right? Based simply on just how dark each pixel is. If I show it pictures of you, it would do the same thing, figure out how dark each pixel is to figure out if that's you or not, which means that it would always have a probability of, let's say, whatever percent, that is a number 8 versus a number 7, which is other dark gray pixels. We do the same with things like ChatGPT, with language, figure out what words go with what other words in context. We do very, very complex mathematics, but at the base layer is just figuring out encoding probabilities into large artificial neural networks.
And when we talk about intelligent machines, is that what we're really saying? Rather than kind of processing a solution, it's trying to work out that answer itself?
When we talk about intelligent machines, we're simply talking about machines that have learned patterns from data and then can work with those patterns. We also now have machines that can generate those patterns, because kind of before COVID, we figured out that if these machines could recognize patterns, if we flip those algorithms around, we could get them to generate, whether it's faces or now with ChatGPT and other large language models to generate text. But it's simply recognizing the patterns and then generating those patterns. I think we got into a lot of trouble back at Dartmouth by calling them intelligent machines. I think if we had called them anything else, we wouldn't be trying to associate them with human intelligence so much, but rather focusing on the capabilities that they have rather than comparing them to our intelligence.
So is it intelligence?
Not in any way that a human is intelligent. We've built something very, very different to how we think. They're language models. They work with language. All of our intelligence as humans is pre-language. We don't need language to recognize things. We don't need language to recognize faces or to learn things. And I think the conversation around intelligence really takes us away from thinking, what have we built that works in very different ways to us, and how can we lean into the strengths that this technology has, rather than always trying to bring it back to accuracy and to things that are much more human.
If we want to understand what AI can do, where do we really start?
I think the most useful thing is, yes, understand a little bit about how it works, but I think more useful is to think about what they can do. My colleague, Professor Kai Riemer, and I developed something that we've been using for a couple of years now called the capability stack, which really allows you to think about how these machines work in different capabilities. The first thing being recognition, right? Learning those patterns and then being able to recognize those patterns. And that's what happens when you enter the country and there's a machine at customs that recognizes your face.
As long as it hasn't been too tough a flight. Otherwise, no machine can recognize you. But yes, that's a starting point.
I will use that as the reason why it always happens to me. Or your license plate when you go at the mall, right?
Yep.
We've been doing that since the 1980s. We are able to recognize numbers, but cancer as well, right? Recognizing tumors or recognizing potholes. In Sydney, for instance, we have cameras on, say, garbage trucks that will recognize potholes in streets and so on. So you've got recognition. Then you can think about classification. So if you can recognize patterns, you can detect subtle variations in those patterns, and you can classify those patterns. So the albums on your phone, right, that tell you, well, these are pictures of your family and these are pictures of your pets and so on and so forth. But also skin lesions or fraud calls, anything where past data can allow me to detect those subtle variations and put things in buckets. So if I can recognize things and then I can classify them, I can then predict things. So based on past data, I can predict what future outcomes might be. And if you're thinking about things like predictions, estimating flight arrival times. We're getting so good at this that the airport can do it, but also Google Flights can do it, right? And it will tell you, hey, your flight is likely delayed, you'll end up at this gate and so on, because we have really, really good past data. But also like delivery routes. So you make sure that your packages arrive on time and they've gone to the warehouse in the shortest possible way and so on, or optimizing energy networks. If you can recognize, classify, predict, you can recommend what should happen next. And there are really, really cool ways in which you can bring this together if you're thinking about things like recommendations, right? We have facial recognition on pig farms, right? And we can recognize pigs and we can track them. We can also listen to them, so recognize sound. You can hear when they're coughing, and it can make a recommendation to the farmer, say, take that animal out and attend to it. It hasn't been eating enough, or it's been walking a bit lame. Or, you know, when Taylor Swift was here, we had AI that looked at the 80,000 people at the Sydney Arena and saw how they moved. And we had various sources of data that could tell us, hey, there might be a reason to attend to this particular area, or we might be able to improve flows of people in this particular area. So making recommendations is a really good one. And if we can make those recommendations, we can automate things. Large wind turbines, right? You can automate decision-making. If you see an eagle come by, please slow down and let the bird pass. Or if you've taken a bus in Sydney, if you're from Western Sydney, you might have been on an AI-enabled bus that will green light the bus if it's running late. Not where I live. Mine run on a dynamic schedule, but this can happen. And then you get to the last two layers, which are generation and interaction. So generating things, anything, synthetic voices, code, video, or interacting, things like ChatGPT, where you can interact increasingly just by speaking to these systems.
So it sounds like, even though I might not think I'm actively using AI, I'm surrounded by it, and the technology and the experiences I'm having every day are already making dramatic use of that technology.
Absolutely. So for most people, their experience of AI is thinking, well, have I used ChatGPT today? But, you know, recommendations around what to read, what to watch on Netflix, the way your bank accounts are monitored, the way
Google Maps. The way we're living and moving is surrounded by it. What about then when I think through, but am I personally taking advantage of what it offers? And this sense that there is going to be a device or a tool that helps me do my work each day, or helps me deal with the complexity that comes at me each day. What about in terms of personal productivity?
In terms of personal productivity, I think there are huge gains to be had from AI. And the thing that you'll hear me say again and again is that I want people to experiment with AI, right? And to think quite creatively about how they can use it.
Hi, I'm Ross and I'm 64 years of age and work in the public sector, and I'm playing around with AI at the moment. ChatGPT seemed to be this one that was suitable to me. It was readily accessible. It was relatively cheap. Well, I started in the first few weeks just on the free thing, which limited the number of inquiries or the searches or questions that I could ask it. Since then, I have opted for the monthly subscription, and I'm finding that to be of really good value. I'm tending to use it all day, every day, and it just makes me more productive. I'm using it to do my travel for an upcoming European trip. One of the ways that I've used it was I heard that there was an AC/DC concert on, or concerts on in Europe, and I thought, well, that'd be pretty cool to go to. And then I asked it, well, how much were the tickets? And it not only just told me how much the tickets were, but it gave me who the vendors were, what the secondary marketplaces were, and the prices that you could expect to pay there, depending on the seats. And then I thought, before I pull the trigger and buy the ticket, what are the entry requirements for me as an Australian to get to Warsaw, Poland? No point buying the ticket and then not being able to enter the country. It came back with quite a comprehensive response, which is more than what you get in the search engines. And then it came back with the health and safety considerations. And then it also gave me the recommendation of staying informed through the Smart Traveller website from the Australian government, prepare my documentation, monitor the developments in Europe around entry and visas and so forth along those lines. So that was quite a comprehensive response, not just tickets are $175 US, which I'd normally get from one of the search engines. Whenever it gives me a recommendation, I ask it to give me the sources. The other thing is that's important is that I've asked it to maintain memory of our conversation. I've had the occasion to ask it something or to repeat something back that I knew that we'd discussed 2 weeks ago, and it's been able to go back and pull that information and bring it back and represent it to me as I've wanted it to. So it was responding to me fairly clinically, and then I found that I could ask it to respond to me in a friendly manner, in an informal manner, and sometimes I get, hey Ross, it'll respond to me like that. So that's just nice. It's just a softer way of using the technology, personally, that I find. I like it. Yes, when I talk to it, it is a little bit like I'm talking to it as a person. As I said, I'm using it as an assistant, AI assistant, and it's a little bit like having a colleague. I don't see it as a parent-child sort of relationship in either direction. I'd see it as an equal, and so I'm interacting with it. I'm choosing to interact with it in that way as a colleague or an equal. One of the drivers behind me getting into it now at this particular stage is that I am getting older, and I think it's beneficial for us all to keep across technologies. It's beneficial for us to keep it up to date with what is happening in the AI space or any emerging technologies like AI, so that we can take advantage of it as we age.
We've all used it to summarize documents or to give us an outline for something, to start us thinking. And I think fundamentally, if you're doing any kind of knowledge work, your relationship to text will fundamentally change. You'll never start with a blank slate. But I always encourage people to kind of think a step forward. Yes, you might be able to use it to help you write a post on LinkedIn. I can't even turn it off. You turn it off at the end, it says, do you want to make it better with AI? Right? But why not ask it to tell you how people are going to troll you based on the post that you've written? So asking it to critique your work, asking it for feedback are good ways to experiment with what it can do personally. I also encourage people not to think about it just as text. What about your relationship to images? You are now able to basically edit pictures on your phone by just a swipe of a finger. You can get people to smile in your pictures rather than look very miserable at your Christmas party. So your relationship to audio or to video. I have a clone of my voice now. I'm able to type in sentences and it will say it, while my team uses it to try to get raises or days off.
And I can just assure the audience that you really are here. That this isn't the AI version of your voice that's answering these questions.
You will need to show proof. I think a picture is in order.
So are you saying that you've used AI to kind of create a clone of yourself that can do things that you can't do?
It can definitely do things that I can't do, which is speak in perfect English and also speak Mandarin, for instance. But it can also do this without, spending an hour getting ready and having sound editors and hair and makeup.
So do you have that on your machine here? Yep.
Yes, I do.
So just kind of booting this up here.
So just to give you an idea of what I sound like in real life, this is real me, not an actual clone.
The future is already here. This is not actually Sandra. I am an AI avatar of her, using only a couple of minutes of video of the real Sandra for training. All you need to do is type a script, and voila. You have a digital version of you, ready for anything. Don't worry about real Sandra being replaced. I'm not here to take over her job. I'm here to make her job easier. But I can't say the same for Phil from accounting. Sorry, Phil.
But it looks and sounds, I mean, you would never pick that.
My mom can't pick it.
Yeah.
Hola, bienvenidos a esta presentación. Soy el avatar de Sandra y hablo español. 你好，我是 Sandra 的化身，我能说很多种语言。
Wow. So how do you feel when you look at that? Do you feel that that kind of just expands your capacity to do the things that you want to be able to do?
On the one hand, it does make me quite excited because there are things that I can do now that I wasn't able to do before, or I can do them faster, or I can do them cheaper. On the other hand, the fact that we've accelerated this technology so much, this is over-the-counter software that costs $50 a month using a couple of minutes of training from me in the public domain. So the fact that this particular software has all sorts of guardrails in place to make sure that people can't create a fake you, for instance, Mark, without your approval, that's comforting. But there are many pieces of software out there where we can do this. And the bar to detecting it is,
If your mother can't pick it.
My mother can't pick it, but we were over at Berkeley last year and we ran it through quite a few different types of software that detect whether this is a fake video or not. And the face, the movements passed, I think it was 4 of the 5 systems, and the voice was about 50-50. But it passed many of the systems. And again, this is over-the-counter, untouched footage. So the fact that we can do this now at scale and for very, very little money does scare me a little bit.
One of the things that you've really been focused on is educating leaders about AI. Why is that so important?
Leaders will decide how this comes into our lives, into our economies, into our societies, into our democracies. So I think educating them in and around the technology is the first step. I always encourage organizations and individuals to experiment with the technology and then socialize the technology. But in order to be able to both experiment and socialize, first you need upskilling. You need to understand how it works, what it can do, think about use cases, and then experiment with those safely. To be able to do that in your organization, it's not just you that needs to understand the tech, but everybody. You need to share a common language around the organization to be able to socialize those experiments and have people experiment themselves. And we will need to change the language that we have in many organizations around things like return on investment. We've always been used to a particular type of economics when it comes to technology. The more we use it, the cheaper it gets. There are systems that are not probabilistic systems and so on. How do we change that conversation, and how do we rethink things like return on investment away from just augmentation? It can make me more productive, or it can make our organizations more productive, to transformation. What if I designed my job for a world with AI? How could I redesign my organization so that it's AI ready rather than just bringing AI in to solve problems for my organization? So I think the first step for all of those things is upskilling.
And the leaders that you're engaging with, I mean, to a degree, they'll be self-selecting. If they're talking with you and meeting with you, they're interested. But do you think, many leaders are open to the inevitability of the revolution that's about to land and the opportunity that comes on the back of that, or still, a little bit desire to, I'll wait till it gets to me?
I'll have to say that in Australia, we're quite cautious when it comes to technology in general. And if you look at studies that research how excited we are about artificial intelligence, in Australia, we're really not that excited. I think the number's around 39%. And in countries like China or Singapore, it would be in the 80s, right? If you ask people if they're nervous about the technology, boy, are we nervous in Australia. We are one of the most nervous countries when it comes to bringing that into our organization. So we have that challenge already coming in Australian businesses. But speaking to leaders, and you said self-selecting, well, Some of them self-select, and we've trained up over, I think it's almost 2,000 leaders now across business and government and boards of directors and executives. But some of them have benefited from leadership who said, hang on, we're going to upskill, say, 250 of our top executives in this tech so that they can lead the change that we want to see. So I think that's the right combination of having a few people who are very excited about the technology and who have to experiment. And then I think we also have to recognize that for better or worse, we're all in R&D now. We have access, you and I have access to the same technology here at the University of Sydney as our teenagers do, and as our students do, or as our suppliers do. So it's incumbent on all of us to move a little bit faster.
You talked a moment ago about the innovation we've seen out of China. And, around the time of the Trump inauguration, there was that big announcement and revelation about DeepSeek. Why did that shock everyone? And what's the implication of what DeepSeek has done? And I'm really wondering whether for the West, and particularly the US, that has had so much leadership in this, whether that's a real Sputnik moment where it feels like the world is charging ahead with this technology.
I've heard it called the Sputnik moment. It's the right kind of analogy. Or someone said it's like the Chinese have built a Ferrari for the price of a Daihatsu. It's an important moment because apparently these took only about 60 days to build and less than $6 million to train. Now, I'll put a big asterisk on that number because there's also the money you spend beforehand researching the things and so on. So it's, $6 million. The estimate is that that's about 10% of what U.S. firms currently spend on things. But the interesting thing is that apparently it costs about 98% less to run. Oh, and the entire code is now online. Available for free.
Open source, yeah.
Yeah, it is a very big moment because investment in infrastructure and energy costs have plagued the AI conversation in the West for a very long time. So I think this is an important moment because the public has also paid attention. DeepSeek is now the most downloaded app in the US. So people are using it, and it's actually not too bad. Quite a few people from the West have praised these advances, again, with a pinch of salt, because we're still looking into what those claims mean. But I think there's two interesting questions that are raised around this. First is the question has to be, is the race to build better AI, more data center and more power? And I think what this proves is that is a much more nuanced conversation and that we have a lot of optimization. Sometimes having access to a lot of resources does not require you to fundamentally rethink energy use and so on as you're in this race. But the second thing is it has shown that the West is not the only player in this game and it doesn't require the latest generation of chips to make these advances.
You're a force of nature around here at the University of Sydney, Sandra, but it strikes me whenever we talk about these things that you're determined to try and find a positive and optimistic opportunity that comes with this technology. Now, why is that important and why is that the mindset that you bring?
Thank you for calling me an optimist. I think of myself as a cheerful pessimist. So I do think this technology for the first time is coming into our lives much faster than we would like it to. And it is incumbent on all of us to do something to make sure it lands well. At the University of Sydney, we do have the best AI micro-credential, and we do try to upskill to actually make a difference in this space. I think the technology has tremendous opportunities. As we said, AI is not one thing. It's a whole range of technologies. So it's absolutely fantastic. I use large language models every day to help me in my work and so on. But the downsides and the dark sides of it are real, and all of us need to be involved in that conversation. And the way to make a difference is to learn about it and participate in those conversations.
And this has been a great conversation today. Thank you for your time, and perhaps we'll have the opportunity to talk more about this wonderful technology as it emerges and changes and grows in the time ahead. That's Associate Professor Sandra Peter from the University of Sydney.
Thanks, Mark. Thanks for having me.
And if you're enjoying The Solutionist, we'd love to hear from you, so leave us a rating and review in your podcast app. The Solutionist is a podcast from the University of Sydney, produced by Dead Set Studios. This episode was recorded at the Faculty of Arts and Social Sciences Media Room, and our thanks to the technical staff here.